segmentation. And we have these two versions of our email that we're sending out. We have A and B that we split across segments X and Y. So the first step here is to transfer this data set over to Excel, which we've gone ahead and done. So all I've done is basically just take the same information and plug it in to Excel here. The next thing that we've done is to take this information and split it up amongst the different groups. So the first one that I split up is X and Y. So I took all of the X's and I put them here, and all of the Y's and put them here, regardless of whether they were A or B. We're going to see if there's any significant difference between those. We're going to do a little bit of summing and differencing to see what that may bring us. And we also want the information for A and B. So we took the information from XA, put it there, YA and put it there, XB, put it there, YB and put it there. So we have all of the A's and all the B's here. We're going to see if there's any difference between the two versions. We may find significant difference between them, regardless of which segment they're attached to. And then we have our other things over here, which is XA and YA. We're going to look at differences between the values in XA, so just these 5 values up here, and YA, see if the same email across the two segments is significantly different, and then the same for XB, so the B version, is it different across those two segments. That should be enough information to give us what we need. We're going to then take a look at stating our null hypotheses. We want to make sure that we're comparing one, whether there's a difference in clicks between the two versions of the emails. There's a difference in clicks between two segments. So we're going to, when we create those hypotheses, we're going to, before we run our t-test, we're going to think about how we're stating these things, because we're going to run effectively a t-test for each one of these four cut down data sets. Then we're going to interpret the results the same way that we always do. We're either going to reject the null hypothesis or fail to reject it. And then after that, we're going to submit this as an Excel file to assignment 6. There's no reason to do a Word file. All of the information can be contained on a single sheet. So from there, we're going to get started on this. So we have these two groups. And we're going to go ahead and just start with our summative and differencing data. So the first thing that I always do here is to do simple sums for each one of these, just to see what we're coming up with. And I'm going to do them across all of our values. All right, what we see here is we see there is some numerical difference. I don't know if there's a difference in the means yet, but I see there's some numerical difference between X and Y. There is this similar kind of difference between XA and X. It's significant yet, but we can start to see it. The next thing we're going to do is we're going to do just a simple difference between the two. And we could make this a little bit complex. We could maybe take the difference of the averages. That may be more statistically sound. Or we could just take a difference of the sums. That may also work as well. To show you what both of those would look like, I'm going to do the simple difference, and then I'm going to do the average difference. So for a simple difference, it would be... actually, I'll put in here, we're going to say sum difference of sums. That's going to equal y minus x, and that gives us negative 107. That tells us that that there is a difference of 107 between y and x. We're also going to do average difference. And this one is slightly more complicated. calculation, but it's not too bad. It's just average of all the y's. Remember to close that parentheses, minus the average of all the x's. And we get that. I'm going to do the same for all of the other ones as well. So here we get the differences in sums for y and x is 107, or rather negative 107. That means that y is 107 less than x. And then the average difference is negative 10.7, meaning that the average of y, or the mean of y, is 10 less than the mean of x. The difference for a and b is 61, meaning that the sum difference is 61 greater for b than for a. And then the average difference is 6.1, meaning that there is that the mean for b is 6.1 larger than the mean for a. Same thing over here. We have a negative summative difference between ya and xa, and a negative average difference between ya and xa, which we would expect. And then the same thing over here. Now, these two numbers are just there to inform us sort of how the wind is blowing, sort of, for these things. We just want to know in what direction are they moving. In this case, we're trying to see if there's a difference between the segments. We're predicting that there will not be, or there will be, but we're trying to just see if there's a difference, and now we know that that difference is actually a negative difference for y compared to x, positive difference for b compared to a, negative difference for ya compared to xa, and negative difference for yb compared to xb. And that really is showing us sort of these things over here, that there is a small, the segment in for y does, numerically at least, maybe not statistically, but at least numerically has fewer clicks than the x segment. Now we're going to actually start thinking about our hypotheses, and we're going to do 4 separate hypotheses, only 2 of which are actually really important for our analysis, but whenever we do a t-test, we want there to be a very clear hypotheses for each one. So I'm going to write those down here, and we're going to take a look at them in a second. All right, so we have our 4 hypotheses here, or 4 sets. So we have for our first set, we have our x and y set. Our null hypothesis is there is not a significant difference in clicks between segments x and y. Our alternative hypothesis is there is a significant difference in clicks between segments x and y. For a and b, for this set, there is not a significant difference in clicks between version A and B. Our alternative hypothesis is there is a significant difference in clicks between versions A and B. And then our sort of test over here, which this is less important than the first 2, but these are still, I feel, important for us to really understand the data. There is not a significant difference in clicks within version A between groups X and Y. There is a significant difference in clicks within version A between X and Y, and then this one down here is the same for B, version B within X and Y, and version B within X and Y. So now we can just do our t-tests, and we're going to do it the simple way. We're going to do the t-test using the function in Excel. We're not going to go and pull a big output. We just want to see what the p-value is. So we don't want to get confused with other things. So we're just going to pull that. So here I'm going to put the title for this test is going to be t-test p. So, or I can even do p equals, and that will tell me what this is going to be. So remember, to do a t-test, it is equals t-test. All right, that gives us this, and we just start pulling in our arrays. So our first array is x, comma, y, comma. We're going to do 2 tails because we want to see if there's any difference whatsoever. So that's 2, comma, and then the type is equal variances, which is 2. Close that bracket, and we get our t-test. The first thing that we need to do is we need to change this to a number that is understandable and readable by us. We're going to change that to a number. I don't really have to change this, but I am going to increase the number of decimals until I find until I see a number other than 0. All right, I'm going to show you how to do that one more time here with this one, and then I'm going to fill in the rest and we'll talk about it. So that's equals t-test, the first array, comma, the second array, comma, two tails, equal variances, and we get this value here. Okay, and that's, it already has plenty of decimals for us to look at. All right, I'm going to do the same for these over here. All right, so we have the p-values for each of our two-tailed tests for xy, ab, xa and ya, xb and yb. Let's take a look at them. We have a very small p-value for our xy t-test, and knowing that from the assignment, our significance level that we're looking for is 0.05. That's our alpha. We can look at this and say, all right, is this less than 0.05? Well, yeah. This is less than 0.05. So, if we're going to do an interpretation of the xy, remember we have our null hypothesis of there is not a significant difference in cl6 between x and y. There is a significant difference in cl6 between x and y. Then our interpretation of x and y, that t-test is we reject the null hypothesis. Maybe not have a big... All right, so we reject the null hypothesis. That's our interpretation. Our conclusion can actually take advantage of this other numerical information we found. So we found that there's a negative difference between x and y. What does that mean? The y segment clicks fewer times than the x segment overall. So we have rejected null hypothesis, and then our conclusion is the y segment clicks fewer times than the x segment overall. Right? That means that over all of this, we're likely going to see that negative correlation play out. All right, how about the next one? The next one we have our AB t-test. So in this case, we have a p-value of 0.0376. That is for a two-tailed test. Yep, that's for a two-tailed test. So our interpretation of this, is this less than or equal to 0.05? It is less than or equal to 0.05, so again, we reject the null hypothesis. And then our conclusion, since there is statistical significance here, our conclusion is going to be version B gets significantly more clicks than version A. Simple as that. All right, now just kind of, and that's the reason why we know that is because there is a positive difference between B and A. The B has more, has a positive difference to A, so there's more clicks for B than there are for A. If we saw that reverse, we would know that even though we would still reject null hypothesis, we would say that version A gets significantly more clicks than B. But we see a positive difference, so it's the reverse of that. How about for XA and YA? Is there a difference within the version between segments? And the answer to that is yes. This p-value is less than 0.05. So again, we reject the null hypothesis, and then we're looking at another negative difference. And I can word this one many different ways through our conclusion. But I can kind of interpret this based on the other information that we have over here. Is that the y segment difference persists within version A. So I don't know why I keep saying segments. The difference that we saw up here in the x and y interpretation and conclusion, we're also continuing to see that in just within version A. And we look at this one. This is kind of the same. This is actually even more different for B, because we see a lower number here. There is significance here. So again, we're going to reject the null hypothesis, and our conclusion is the y segment difference persists within version B. All right, knowing all that, what we really find out about this, the entire conclusion, now this is all you need to do, this is all I'm going to write down, but the entire conclusion here shows us that B definitely gets more clicks There is, however, a significant difference between segment X and Y. So B is still getting more clicks, but Y clicks less than segment X. So if we were going to focus on anything, we would almost certainly focus on segment X and version B. That would be our choices here. Segment X tends to click more overall, and version B garners more clicks than version A. That would be my interpretation for this. With that, I'd save this file and submit it as is. Make sure that your hypotheses and your interpretations and conclusions are very cleanly done. This is a very easy assignment if you have it all clean like this. Submit it as a single file on a single sheet, and I'll grade it as such. Thank you very much.